Hi, this is Lori, and welcome to my series on the Pico W. In this episode, we're going to put the W in Pico W. It's time to get our Pico on our Wi-Fi. In this episode, we'll also learn about RGB LEDs and an Internet of Things project called CheerLights. Let's get going. Let's first talk about RGB LEDs. They're an LED that has 3 LEDs inside, a red, a green, and a blue LED inside it. They'll look different than the LEDs we've used so far in the fact that they have 4 legs. The longest one is usually the ground, then the other 3 are the 3 colors, and that's how we'll individually control the red, green, and blue colors inside the LED. The most common one that I've seen in beginning kits are usually common cathode, meaning that the 3 colors all share the same cathode. But there is also common anode where they share the same anode instead. This one you would connect up the long lead to ground, and in this one you'd connect up the long lead to your positive rail. How do you tell whether you have a common cathode or a common anode RGB LED? There's no marking on the outside that lets you know, at least as far as I can tell. And the best way is to use your multimeter. And you want to hook up the long leg to ground if you suspect you have a common cathode, and then connect, for example, the red lead to your positive, and then put your multimeter on your continuity mode. And if it's a common cathode, that should set it up that the red light will appear. So you can see here is an example of me doing that with the ones that I have. I found out on the internet another picture of a common anode. I don't happen to have one in my lab at this time. And you can see you would do the opposite in that case. You take your long lead and connect it to the positive and your red lead to the negative, and you'd light the LED, the red LED inside if you have a common anode. So that's probably the best way that I know of to be able to tell which one you have for sure. Here's the circuit we'll use for this project. I only needed a half-size breadboard for this project, but you could certainly use a full-size one. We'll put our Pico on, and you may notice that I'm going to slide the Pico over a little bit to leave me extra room on this side so I can connect up the red, green, and blue leads from our RGB LED. So I left myself a little more space. Then we'll put our RGB LED in, and you can see the 4 leads. Here's the long one, which I'll connect into ground. As you can see, here's the little label that came with my RGB LEDs, and it tells me that it's an RGB. Other thing it tells me is the long lead is a cathode, so I know I have a common cathode. The other nice thing is it tells me the forward voltage needed for the red, the green, and the blue, so that can help you choose your current limiting resistor, and I did that in a previous episode, which I'll link below if you want to look at that. So that's nice to keep around, and I actually have that kind of taped onto it so I can remember that these are a common cathode and what the forward voltages of them are. So you can see that since it takes a lower forward voltage for the red, I went ahead and used a little more resistance, and then I used a little less here. These are much more resistance than I would really need if you do all the calculations to figure out what resistor you want, but it certainly works pretty reasonably well, so that's what I chose to do. And then you can see after the resistors, I connect each up to GPIO pins on my Pico. So pretty simple circuit, and I think we'll have a lot of fun with it. So to connect up our RGB LED and start programming it, I decided to use the picozero library. Now I haven't used the picozero library so far in the episodes for the Pico W, but I thought this was a great time. The picozero library, I just show a picture of the website for it. You can see it's a beginner-friendly library for basic electronic components to connect up into our Raspberry Pi Pico, and it really makes using some of those components significantly easier. So you may want to go here and read up on this library, and here's the link for it. To use the library, we'll need to install it through Thorny and the Manage Packages selection so that we can have it available and use it. Let's first try using our RGB LED with our picozero library, and then we'll come to getting our Pico on the Wi-Fi and eventually get to our CheerLights application. Let's start first with just getting the RGB LED going. And you can see I have my circuit all set up on the half-size breadboard here with my RGB LED, the ground leg connected to the ground rail, the current limiting resistors, and they're connected back to GPIO pins on our Pico. Next, we'll need to set up the picozero library. So I've done this before, so I'm just going to mention it. In the Tools menu, you'll select Tools and then Manage Packages, search for picozero, and click the Install button, and that'll get that picozero module or library available to you. This program I just got from the picozero docs. It just kind of runs the RGB LED through its paces and shows you a little bit about how to set it up and how to control it. So we'll set up our RGB LED object and tell it what GPIO pins we're using to control the red, green, and blue. And you can see here we'll control the red using this dot red. We can set it anywhere between 0 and 255. 255 is full intensity of the red, and 0 would be the red being completely turned off. So halfway would be 128. Then we can just say on, and that's going to turn all three of them on full, which actually gives you a white color. And you can see here are some other blends of colors, full green. Here we're blending red and blue to get magenta, and then we can get yellow and cyan, and then here again is the white, but controlling it this way by turning all of them on. And then we could turn them all off by saying 0. And then we can increase the intensity of the blue by going through 0 to 255 very slowly using the sleep function. Now we could also turn the RGB LED completely off using this. So we can turn it on for white, we can turn it off to turn it completely off, or we could use the numbers as well. So multiple ways to go about this. Let's run this program and see how everything looks. It's going through its paces, and hopefully this little black piece of paper might be making it easier to see the colors on the screen. I'm hoping that it works. It's hard to capture these kinds of colors using video cameras. There we go. It's complete. So it looks like we have everything hooked up correctly, and now we're ready to try to get this baby onto our Wi-Fi. It's a great resource from the Raspberry Pi Foundation. This website here will walk you through getting your Pico connected to your Wi-Fi, and then also doing a little project where you create your own web page and control an LED from the web page using your Pico. So it's a fun little project to do, and I highly recommend going through and reading this excellent resource. We're going to use the code that the Raspberry Pi Foundation put together to connect our Pico W to our Wi-Fi. When we have our Pico connected to the Wi-Fi with our RGB LED circuit all set up, we'll be able to use the CheerLights project. And as I said before, the CheerLights is an Internet of Things project where lights all around the world are synchronized to the same color. And the color can be set by anyone using Discord or Twitter. And you mention CheerLights and a particular color, and all the lights connected to CheerLights will change to that color all around the world. It's really kind of a super cool idea. And you can see you can tweet or go on the Discord server and mention any of these colors, and that'll change everyone who has a project connected to CheerLights. That'll change the color of their light. So a lot of fun to do. Behind the scenes, the CheerLights listens to Twitter or Discord for @CheerLights or hashtag CheerLights and these color names. So that's how it waits to hear from that, and then it looks for these colors and it'll go ahead and make that change. We're going to connect up to the CheerLights API so that we can make our RGB LED connected to CheerLights and change the color whenever somebody changes it with Discord or Twitter. I'm at the CheerLights.com website just to show a little bit about what we're going to try to do in our program. And here's where you can get a lot more information about CheerLights and how to connect up all different kinds of things and use all different kinds of ways of connecting up to it. From the Learn page, this is where you learn a little bit more about how everything works. And you can see the CheerLights ThingSpeak channel, and we can use the API to get the last color that was set using either text or hex color value. So here's the last color name in text or in hex. So that's what we're going to use. We're going to use the hex color value. And if you click on here, it'll take us to that, and we can see that this is what we're going to be grabbing once we make all this connection. We're going to grab this hex value for the color so that we can set our RGB to this color. So the first two digits in hexadecimal will give us the red, and the next two digits here will give us the green, and the last two will give us the blue. So if you remember from our program, the picozero library wants numbers between 0 and 255. So we're going to have to translate these hexadecimal values into 0 to 255. So we'll need a little function to do that conversion, as well as having some sort of function so that we can get on the Wi-Fi to make a connection to the CheerLights API. That's where we're headed next. Finally, time to put some code together to get on the Wi-Fi, and we're going to connect up to the CheerLights API. All we're going to try to do is get that hexadecimal color value and print it to our shell and do the conversion to the 0 to 255 scale that we want for our picozero library. We'll need to import several modules to do the connection to our Wi-Fi and to get to the CheerLights API. Now you'll notice that my program starts at line 10 because above this I've put my actual Wi-Fi name and password at the top. You'll want to uncomment this part of the code and put your own Wi-Fi network name and password. Now some people get a little nervous about this because you're coding up your password to your Wi-Fi in this program, and if somebody got a hold of your Pico W, well then they would have your password to your Wi-Fi, and that's definitely true if somebody was smart enough and realized that that's what that was. Sometimes people put these in a separate file that they call Wi-Fi info or secrets. I'm not sure that makes it any safer because it's still available, but I just decided it's simpler just to put it right into my program, and I figured if I ever lose one of my Pico Ws, then I'm going to change my Wi-Fi password. So that's how I'm going to handle my, my security. All right, so the first function we'll put together is to get our Raspberry Pi onto the Wi-Fi, and this function comes directly from the Raspberry Pi tutorial that we discussed earlier. So we'll use the network library to set up an object to connect to the Wi-Fi, and we'll go ahead and give it our name and password, and it's going to run into this loop until it gets connected. So it's going to keep trying to connect until it makes a connection, and then it'll assign the IP address that we got. We're going to print that out to the screen and return that. So that's the function we'll use to connect. And then we have a function here to do that conversion of the hexadecimal value for the color to the RGB format that we need for our picozero library. And so we'll pass it the hex value. We're going to strip off that hashtag at the start. We'll print both of those out so we can make sure that that's working. And then we'll convert those hexadecimal pieces, the red, green, and blue, so those first two digits, the middle digits, and the last two digits, from hexadecimal into an integer. And that'll get us onto the 0 to 255 scale. In this particular program, I'm doing a lot of printing to the screen just so we can see how it works. So we'll print those out. We'll return those as a tuple, because if you remember, we can control using the picozero library using a tuple of the three values for red, green, and blue, and we'll return that. Then in the main part of our program here, we're going to give the URL to get that last or the current color from the API for CheerLights. We're going to go ahead and connect. So I'm going to say getting the current color. We're going to send out a request to that URL. We're going to return that as a CheerLights object. And then we're going to pull off that field 2. That's where the hexadecimal value was. And then we'll print that after we've done this conversion, of course. We'll print that to the screen and close the connection. So let's go ahead and give this a run. Connected very rapidly, and you can see here's the current color, and the current color is blue, full on blue, 255. So we've made our Pico get onto our Wi-Fi, and we've connected to CheerLights and gotten the current color. So we're all set to go. Now we're going to make our final program, and we'll go ahead and light up our RGB LED using the current CheerLights color. The final code for our CheerLights project, we'll import the needed modules, including the picozero for the RGB LED. Here's where we'll put our important information for the Wi-Fi and the connect function that we've already talked about before. And a couple more functions are added in here to get the current hex value, and I also wanted to get the current text value to print that to the screen. So this is the code that we ran kind of in the main part in version 1. Went ahead and made a function for that so that we can get that color and then do the conversion using our hex to RGB function and returning that color. And then here I'm using the text value. So you might remember when we were on the website for CheerLights, there was a text part that we could ask for the color as a text. So that's all I'm doing here is using that. And all the same kinds of code and just returning the text name of the color. Here's our hex to RGB function that we've talked about before, and setting up our RGB LED. And now we're going to use our try and accept so that we can gracefully end the program. We're going to go ahead and connect, and then we'll have a while true loop so that we'll keep going. So this would be run all over and over again and continue to pull the CheerLights every 60 seconds, so every minute. And probably if you're going to set this up and power your Pico W separately, you probably want to set that to something more like 5 minutes or 10 minutes. The color doesn't change that often, and you probably don't want to continually pull the site this frequently. But as we're just getting started, every minute seems good enough. So we'll go ahead and get the hex value, we'll get the text value, we'll print those to the screen, and we'll set our color of our RGB using the color that we got from our get hex value function. And we'll check that again every 60 seconds, and if we do our keyboard interrupt, we'll just turn the RGB LED off and end the program. Let's run this one. There we go, got connected, and the current color is blue, and yeah, we got blue in there. And I'll go ahead and let this run for a minute just so we can see it run again. It's pretty unlikely it's going to change colors on us in 1 minute, but it does happen every now and then. When I was looking, it seemed like about every 10 minutes or so a new color will occur. And if you get this up and running, you can let it sit as you're doing other things and watch the color and see when it changes. So we'll see if we get the next next poll here. Just a little bit more time, I think, and we should see another run and a new print to our shell. All right. Minute is a long time, it seems like, especially when you're on camera. And it's still blue. And that's how it works. We'll go ahead and end the program. And I want to thank you for joining me in this project.